Hello students, in this video we are going to study some basics about magnet which we are going to use in this lesson. So what is meant by magnet? You already studied that the material which attracts ferromagnetic material. A material which can attract ferromagnetic material. मतलब इस तरह का material जो ferromagnetic material को अपने तरफ attract कर सकता है, it is known as magnet. Which are the ferromagnetic material? That is ferrous means iron, nickel and cobalt. These are the magnetic material which can be attracted by a magnet. In case of magnet, we have studied in the last period that it can produce a magnetic field. Magnetic field means what? In the portion around the magnet in which a magnet is effective or magnet can attract an ferromagnetic material. So here I have drawn a magnet. This is the north pole of the magnet and this is the south pole of the magnet. And I have explained you in the last period that the magnet creates a magnetic field which is because of magnetic field lines, I have drawn some magnetic field lines here like this, and I have told you that the magnetic field line starts from the north pole and they ends at the south pole outside the magnet. Means when we are considering outside the magnet, then in that case magnetic field line's direction is from north to south. It's from north to south. But when we goes inside the magnet, then in that case the magnetic field line's direction is from south to north. So outside the magnet it is from north to south and inside the magnet it is from south to north. How I have found that? Because magnetic field lines are imaginary lines. I can't see this. Means if you put a magnet in front of you and you try to watch the magnetic field lines by using goggle or anything, it is not possible because magnetic field lines are imaginary lines, we can't see them. Then you will say that how I have found that the magnetic field line's direction is from north to south. So here I can use how I can find the magnetic field line's direction. That is I am going to explain now. So for that I have done. I have used a magnetic needle. If I put a magnetic needle here, then you will find that its direction is like this. If I put same magnetic needle here, then you will find that the magnetic field direction is like this. If you put the magnetic needle at this place, you will find the direction like this. Means I have to put magnetic needle in this way, then in that case you will find a different direction and different position. And if I draw that direction, then you will get this magnetic field lines direction. Okay. If I put the magnetic needle here, then you will find that the magnetic field lines direction will be like this. Means needle will show you the direction like this. If I put here, then in that case you will find that magnetic needle direction will be like this. Okay. So I hope you have understood how I have find out the magnetic field direction. This is the one way by which we can find the magnetic field direction. There is another way also. If I put a bar magnet here and take some iron fillings and spread it around the magnet. Put one magnet there, take some iron fillings and spread around the magnet. Then in that case also you will find that the magnetic field, the iron fillings will get arrange themselves according to magnetic field lines. Means automatically you will find that the magnetic field lines direction will be there. Means iron fillings will be get separated or get arranged in such a way that it will show you the magnetic field lines. So both these methods we can use to find out the magnetic field lines, and to find out direction we can use magnetic needle. Okay. Then second point. So I have explained you how we can find out magnetic field direction. Magnetic field given by magnitude and direction means it is a vector quantity. Magnetic field needs two quantities. One is magnitude and one is direction. How I can see the magnitude? Because magnet can be of different size. This is a magnet of a bit bigger size. If I use a smaller magnet like this, or if I use a large magnet like this, is all these three cases the magnetic field strength will be same? No. In this case, magnetic strength is quite different. In this case, magnet is large and you may get the magnetic strength much bigger. Means its force can be attract the magnet which is very far from it. And in this case, I have used a very small magnet, so magnetic strength will maybe low. And in that case, the ion can be just attracted from this position. It cannot be attracted from this position. Means the magnetic strength is depend on the size of the magnet, we can say, and also on different factors there. But means all these cases we need the its strength, and strength can be measured by its magnitude. Okay, so magnitude is must, so that we can see we can say that how powerful the magnet is. That can be find out by using magnitude. And the second case which we need is direction. As I have explained you that whenever I have put the magnetic needle, it's showing different direction. Means direction is also important. So magnetic field needs two quantities. One is magnitude and one is direction. And that means it is a vector quantity. Then magnetic field lines are imaginary. That I have already explained you. These lines we cannot see. These are just imaginary line, and I have found that by using magnetic needle. Then magnetic field lines never intersect each other. This is a very important property. As I have drawn here different magnetic lines, these magnetic lines are not intersecting each other at any position. Okay, I have placed one another magnet here. This is the north pole for it and south pole for it. Then in that case, this magnet will also create these magnetic lines. But important thing is that this magnetic line will never get intersected with another magnet's magnetic lines, or these magnetic lines will never get intersected with these magnetic lines also. Means how many magnets you place there doesn't matter. Magnetic field lines will never get intersect to each other. Okay, and that is an important property of a magnet that we have to study here. Then all these things are related to magnet only. But there was a scientist whose name is Hans Christian Ørsted. Hans Christian Ørsted was experimenting with something, and in that case he accidentally found that electric current can produce magnetic field. How it is possible? In that case he was experimenting with some wires, keys, resistances, and one magnetic needle was kept nearby. When he connected the battery to the circuit, in that case the current starts flowing in the circuit, and due to that current he suddenly found that the magnetic needle, which was directing like this, changed its direction from this to this. What does it mean? It means that due to flowing of current in a conductor, the magnetic needle has deflected. Means current have produced a magnetic field lines around this, and due to which the magnetic needle have changed its direction. And that means we can say that current can produce magnetic effect also. As we have studied in the last lesson, current can produce heating effect. In same way, current can produce magnetic effect also, and that is experimented and proved to us by Hans Christian Ørsted. Okay, so these are the all things that I am trying to explain you in this part of